Kids for Chemistry is such a powerful tool because of the patented drawings showing the atoms and molecules with their s and p orbitals and the electrons that are in each orbital. This provides students with a powerful visual, which is much better than the typical drawings that you will see in chemistry. Another outstanding feature of the Kids for Chemistry program is the patented drawing of the periodic table with the sidebar and bottom bar. This is an original drawing developed by Kids for Chemistry and never before used. The sidebar shows how many s orbitals there are for each row and makes it easy for young children to identify an atom and determine which row it belongs in. The bottom bar shows the electrons in the outermost orbital. S orbitals are the outermost orbital for columns 1 and 2. The atoms in the first column all have one electron in the outermost s orbital. The second column has two electrons in the outermost s orbital. P orbitals are the outermost orbital for columns 3 to 8. Column 3 has one electron in the outermost p orbital. Column 4 has two electrons in the outermost p orbital, and so on. This diagram makes it easy for children to identify the atoms. For example, this atom has two s orbitals, so it must be in the second row. And it has four electrons in the outermost p orbitals, so it must be in column 6. Therefore, it must be oxygen. Once again, the Kids for Chemistry drawing provides a powerful visual to help children learn. There is one exception. Helium has an outermost s orbital with two electrons, but it is not in the second column. That is because it is a noble gas, and that is why it is in the column with neon and argon. They are also noble gases. The Kids for Chemistry program provides games that help reinforce the concepts learned in the program. One of the games is called Identifying the Atoms, which is based on the drawings.
When looking at atoms, you can tell which row it belongs in by the number of s orbitals. The atoms in the first row, hydrogen and helium, have one s orbital, so a single s orbital is placed near the first row. The atoms in the second row, lithium to neon, have two s orbitals, so two s orbitals are placed near the second row. The atoms in the third row, sodium to argon, have three s orbitals, so we place three s orbitals near the third row. The atoms in the fourth row, potassium to calcium, have four s orbitals, so four s orbitals are placed near the fourth row. And you can tell which column an atom belongs in by the number of electrons that are in the outermost orbital. The atoms in the first column, hydrogen to potassium, have one electron in an outermost s orbital. The atoms in the second column, beryllium to calcium, have two electrons in an outermost s orbital. The atoms in the third column, boron and aluminum, have one electron in an outermost p orbital. The atoms in the fourth column, carbon and silicon, have two electrons in the outermost p orbital. The atoms in the fifth column, nitrogen to phosphorus, have three electrons in the outermost p orbitals. The atoms in the sixth column, oxygen and sulfur, have four electrons in the outermost p orbitals. The atoms in the seventh column, fluorine and chlorine, have five electrons in the outermost p orbitals. The atoms in the eighth column, neon and argon, have six electrons in the outermost p orbitals. Helium is an exception to the rule because it is a noble gas. You can identify an atom by the number of s orbitals and the number of electrons that are in the outermost orbitals. Pop quiz. What atom is this? It has two s orbitals, therefore it is in the second row. It has 5 electrons in the outermost p orbital. Therefore, it is in the 7th column. It is fluorine. Kids for Chemistry is such a powerful tool because of the patented drawings and showing the atoms and molecules with their s and p orbitals and the electrons that are in each orbital. This provides students with a powerful visual, which is much better than the typical drawings that you will see in chemistry. For example, electron dot diagrams or Lewis dot diagrams are used to show the valence electrons of an atom that are available for chemical bonding. In covalent bonding, atoms share valence electrons in order to get a full octet, 8 valence electrons. Hydrogen is the exception. It forms a duet. The letter X represents an atom with 8 valence electrons, a full octet. The thing about this electron dot diagram is that you cannot see the s orbitals or p orbitals. One of the lone pair of electrons represents an s orbital, and the other 3 lone pairs are the px, py, and pz orbitals. However, a student would never know this by looking at the diagram. The dot diagram for oxygen is compared to the Kids for Chemistry diagram for oxygen. The Kids for Chemistry diagram is a much better visual for learning. You can see the 1s orbital. The electrons on the 1s orbital are not valence electrons, so they are not shown on the dot diagram. You can see the 2s orbitals with the 2 electrons. The 2py orbital has 2 electrons, and it is clearly visualized that it is a p orbital. The 2pz and 2px both have 1 electron. This is also shown on the dot diagram, but it is not clear that they are p orbitals. The concept of hybridization at sp3 orbitals will not be introduced at this time, but it will be mentioned that the 2s orbital and 2p orbitals of oxygen will make a transition after bonding takes place. So, electrons want to be in pairs. They are considered happy when in pairs and lonely when they are by themselves. Both diagrams show where the lonely electrons are and where bonding will take place. Let's look at the formation of the water molecule for both sets of diagrams. We will combine two hydrogen atoms with the oxygen. First, let's look at the dot diagram. The hydrogen atom has one dot representing one electron. You can see that the lonely dot electron on hydrogen combines with one of the lonely dot electrons of oxygen, and then the other hydrogen pairs off with the other lonely electron on the oxygen. But that is all that you can see. However, for the Kids for Chemistry diagram, you can see so much more. You can see that the hydrogen atom has the 1s orbital with one electron, and you can see that the oxygen atom has the 1s orbital with two electrons, the 2s orbital with two electrons, the 2py orbital with two electrons, and the 2pz and 2px orbitals with one electron each. Wow, that is a lot of information. And you can see where the lonely electrons are going to bond. So the water molecule shows you how the hydrogen bonds with the oxygen, and that it is the s orbital of hydrogen that is bonding with the p orbitals of oxygen. Every orbital and every electron is taken into account, and that is why the Kids for Chemistry diagrams make it easy for young children to learn chemistry concepts. As the children move on to high school and college chemistry and are introduced to sigma bonds, pi bonds, and hybridization, the transition is much easier having learned Kids for Chemistry. Another example that shows the powerful visual effects of the Kids for Chemistry diagrams is by comparing them to the electron configuration and orbital diagrams of a typical chemistry book. Here are the orbital diagrams and electron configurations of the first 10 atoms. The orbitals are filled in order of increasing quantum number. The squares represent the orbitals and show that a maximum of 2 electrons can exist in an orbital. The 1s, 2s, and 2p orbitals are shown with the number of electrons. However, it is not clear how the s and p orbitals are positioned relative to each other. You need additional information. Here are the Kids for Chemistry diagrams for oxygen, fluorine, and neon. They show the same information as the orbital diagrams and so much more. Now the students can visually see each s and p orbital and the number of electrons on each orbital, and the student can make an instant connection with the electron configuration and the diagram. You can actually see the 1s orbital with 2 electrons, the 2s orbital with 2 electrons, and the p orbitals and number of electrons in each. And as you go from hydrogen to neon, you will see how the electrons are distributed among the orbitals. In addition, the further away an orbital is from the nucleus, the higher the energy level of the electrons in that orbital. Since the 1s orbital is the closest to the nucleus, it has the lowest energy level. The 2s orbital is further away from the nucleus and has a higher energy level. The tips of the p orbitals are even further away and have an even higher energy level. Even students at the elementary school level can internalize these diagrams of the atoms with their orbitals and the position of the electrons. Building molecules and ions becomes much easier because they can visually see which electrons and orbitals are combining. Learn more about the Kids for Chemistry program and teaching methods at kidsforchemistry.com. Kids for Chemistry books are available at Amazon.